Hello and welcome to Amazing Aircraft. In this video, we are diving into the story of the Boeing E-3 Sentry, also known as AWACS, which stands for Airborne Warning and Control System. This special aircraft can detect and track enemy aircraft, missiles, ships, and vehicles. It also provides command and control for friendly forces. It is one of the most advanced and versatile airborne surveillance systems in the world. It has been used in many conflicts and operations since its introduction in the 1970s. But how did this remarkable aircraft come to be, and what makes it so unique and powerful? Are you ready to dive into its story? Then buckle up and let's go. The story of the E-3 Sentry begins in the mid-1960s. The U.S. Air Force needed a replacement for its aging EC-121 Warningstar, a propeller-driven aircraft used for airborne early warning since the 1950s. The EC-121 had many limitations, such as low speed, short range, limited endurance, and poor reliability. Its radar and computer systems were outdated and could not keep up with modern warfare. The Air Force wanted a new aircraft capable of all-weather surveillance, command, control, and communications. It needed to operate at high altitudes and long distances with greater speed, endurance, and survivability. It also needed a powerful and flexible radar and computer system to process and display large amounts of data while countering enemy electronic countermeasures. To achieve this, the Air Force issued preliminary contracts to Boeing, Douglas, and Lockheed to develop proposals for the new aircraft. The main challenge was to design a radar system capable of scanning airspace in all directions and distinguishing between moving and stationary targets over land or water. This required pulse-Doppler technology, which measures the frequency shift of the radar signal caused by the relative motion of the target. Additionally, the Air Force sought a digital data processing system to filter out noise and clutter, integrating and analyzing information from multiple sources, such as other radars, satellites, or ground stations. Two competing radars from Westinghouse Electric and Hughes Aircraft were selected for further evaluation, both using pulse-Doppler technology but with different approaches and features. The next question was what kind of airframe to use for the new aircraft. Initially, Boeing proposed a custom-built aircraft, but tests showed it would not perform much better than the existing Boeing 707 airliner. The Air Force decided to use the 707 as the basis for the new aircraft, saving time and money while offering proven performance and reliability. The 707 was modified to accommodate the radar and computer systems and to increase its endurance and survivability. The most distinctive feature of the new aircraft was the rotating radar dome, or rotodome, mounted on top of the fuselage behind the cockpit. The rotodome, 9.1 meters in diameter and 1.8 meters thick at the center, was held 3.4 meters above the fuselage by two struts. Tilted down at the front to reduce aerodynamic drag, it rotated at 6 revolutions per minute. The radar antenna could scan 360 degrees in azimuth and 20 degrees in elevation. The radar could detect and track targets from the surface of the Earth up to the stratosphere, covering an area of more than 500,000 square kilometers. The prototype of the new aircraft, designated EC-137D, flew for the first time on February 9, 1972. The fly-off between the two radars took place from March to July of that year. The Westinghouse radar proved superior to the Hughes radar, having higher resolution, greater range, and better electronic countermeasures capability. The Westinghouse radar used a digital computer that could be programmed and modified for different missions. The Hughes radar used an analog computer that was more limited and fixed. The Westinghouse radar also had a beyond-the-horizon mode, capable of detecting targets at longer distances by bouncing the radar signal off the ionosphere. The Air Force chose the Westinghouse radar for the production aircraft and gave the final approval for the full-scale development of the new system in January 1973. The new aircraft was named E-3 Sentry, and the system was called AWACS. The main contractors and partners involved in the E-3 program were Boeing, responsible for the airframe and overall integration, Westinghouse, responsible for the radar and data processing system, IBM and Hazeltine, responsible for the mission computer and display system, and several other companies that provided various subsystems and components. Despite facing many technical and political challenges, such as cost overruns, delays, and opposition from some members of Congress and the Department of Defense, the program received strong support from other influential figures and benefited from the cooperation and participation of several NATO allies. The first production E-3 aircraft was delivered to the Air Force in March 1977, and the first operational squadron was activated in October of that year. The E-3 was initially equipped with the AN/APY-1 radar, which had two modes, pulse-Doppler for air-to-air surveillance and pulse for air-to-surface surveillance. The pulse-Doppler mode could detect and track up to 600 targets simultaneously, while the pulse mode could detect and track up to 240 targets. The radar data was processed by the AWACS computer, which had a memory of 64 kilobytes and a speed of 0.5 megaflops. The computer could perform various functions, such as validation, sorting, summarization, aggregation, analysis, and reporting. The radar and computer data were displayed on 14 consoles, each with a 20-inch color screen and a keyboard. The consoles were operated by a crew of 13 to 19 specialists, performing various roles such as surveillance, identification, weapons control, battle management, and communications. The E-3 could communicate with other aircraft, ships, and ground stations using various radio and data links, such as UHF, VHF, HF, and TATL-A. It could also receive and transmit data from other sensors, such as satellites, AWACS, or JSTARS. The E-3 had a crew of 4 pilots who controlled the aircraft from the cockpit, which was similar to the 707, but with some modifications. The E-3 had 4 TF-33 turbofan engines, providing a maximum speed of 853 kilometers per hour, a maximum altitude of 12,500 meters, and a maximum range of 7,400 kilometers, with the capability to refuel in the air. Between 1977 and 1992, a total of 68 E-3 aircraft were built and delivered to various customers. The U.S. Air Force received 34 E-3s, later upgraded to the E-3B and E-3C standards, with improved radar, computer, and communication systems. NATO received 18 E-3s, registered in Luxembourg and operated by multinational crews from 15 NATO countries. The United Kingdom received 7 E-3s, designated Sentry AEW Mark I with some British modifications. France received 4 E-3s, designated E-3F, with some French modifications. Saudi Arabia received 5 E-3s with CFM56 engines, converting some into RE-3 electronic intelligence aircraft. Japan received 4 E-767 aircraft, based on the Boeing 767 airliner, with radar and computer systems similar to those of the E-3. The E-3 Sentry has been used in various conflicts and operations, proving to be a valuable and versatile asset for air defense and command and control. It has participated in operations such as Eagle Assist, Enduring Freedom, Iraqi Freedom, Inherent Resolve, Desert Storm, Allied Force, Unified Protector, and many others. The E-3 has provided situational awareness, threat detection, target identification, force coordination, and battle management for friendly forces, while countering the enemy's electronic warfare and air defense systems. It has also supported humanitarian and peacekeeping missions, demonstrating its ability to operate in various environments and scenarios, and cooperating with other platforms and systems. The E-3 Sentry has been continuously upgraded and modernized to keep up with evolving threats and technologies. It has received new radar modes, computer systems, communication systems, and self-defense systems, improving its capabilities and extending its service life. The E-3 remains a symbol of American technological prowess and military power, a testament to the ingenuity and dedication of the people who designed, built, and operated it. It has been a witness to history and a participant in shaping the course of events, guarding the skies, and providing hope and reassurance for those on the ground. That's the story of the Boeing E-3 Sentry. Thank you for watching Amazing Aircraft. If you enjoyed it, remember to like, share, and subscribe. The sky is not the limit, it's just the beginning. See you next time!